In this video, we're going to talk about basic log functions. So we're going to be switching back and forth between exponential and log format. So I'm just going to put up a basic example. We know that 4 squared equals 16. Now, if I were to write this, we would call this the exponential form, exponent form, because it has 4 squared equals 16. It shows the exponent. If we were to change this into log form, we read this out loud by saying log of base 4 of 16 equals 2. How I always remember these placeholders is the log equals the exponent. The log equals the exponent. The log equals the exponent. So we can say, because we say log to the base 4 of 16 equals 2. So the base is the thing that I'm raising to an exponent. So I know my base has got to be there. So as another quick example, if we were to say 10 squared equals 100, I would write that as log base 10 of 100 equals the log equals the exponent equals 2. So if you were to put this in your calculator, the common log is base 10. Log base 10 of 100 equals 2. If you put this in your calculator, it would just, you just push the log button and you would say log 100 and it would give you 2, meaning 10 squared is 100. So if we go the other way, and if we were given an example of, let's say, log base 2 of 1 equals what? So we know that log equals the exponent. Log equals the exponent. So if I were to rewrite this, it's kind of hard to judge this, right? Right off the bat, looking at log base 2 of 1, I don't particularly know what that is in my head. I don't keep that in my head. But if I change it around and think about it in exponential form, exponent form, I know that the log equals the exponent, 2 to the x equals 1. I sometimes call this the answer position. That is what the answer is when I have my base raised to the exponent. It equals that. So in this case, 2 to the what equals 1. I know that anything raised to 0 has to equal 1. Even 100 raised to the 0 equals 1. So in this case, we would say x equals 0. The exponent equals 0. This whole log equals 0. So if this were in a whole line of equations with some other logs, 2 to the what equals 1, well, that whole position equals 0. So log base 2 of 1 equals 0. Whenever any base and 1 is in this answer position, the answer is 0 because the exponent is 0. So that's an example of solving for x. Now let's say x is in this position. And let's say our answer was 4. So if we needed to know what x is in the answer position. I'm just going to change now to exponent form. My base is 2. The log equals the exponent. 2 to the 4th equals x. That's our answer. Then 2 to the 4th, I know that is 16. 2 times 2 times 2 times 2. So in that case, x equals 16. So it's really nice because we're able to solve for x in any position. So let's try another one. If I have log base, we don't often have x as the base, but let's just say in this case we did. And this was, if I change this to exponent form now, I don't particularly know what this right off the bat is. But I know my base is x, my exponent is 2 because the log equals the exponent, and my answer, this is the answer position, is 4. What squared equals 4? Well, I know that has to be 2, or it could be negative 2, right? In our adult life, we often say plus or minus 2. Or if I just squared both sides, that would be plus or minus 2. But we could say that is 2. 2 squared equals 4. Log base 2 of 4 equals 2. So that would be our answer there. So another way that we use logs is when we are given exponent form and we are asked to solve. Now in this case it's pretty easy. We know that 2 squared equals 4. But if we didn't, we could change this to log form, and we would say log base 2 of 4 equals my exponent. So often case, if this is something you can just plug into your calculator, we would be able to solve for x. Now we don't often, some calculators do, but most often we don't have different bases. We only have a base 10 in our calculator. So we often would want to switch this and do change of base formula. So I'll cover that in another video. But in this case, this is how we solve for x in the exponent position by switching to the base or to a log form. So that way it brings it down because the log equals the exponent. So this brings x down into a place that I know what to do with it. So if we were given something like x plus 2 or another equation up here in the exponent position, well then I would know that this would be the whole exponent. So then I would solve this side. I know this equals 2 because 2 squared is 4. Log equals the exponent. 2 to the what equals 4? 2 squared is 4. So that whole side becomes 2, and then I could solve for x. So then I would just subtract 2 from both sides, and in that case, x would have to equal 0. So whatever the case is, when x is in the exponent, we can use a log to solve for it. Let me know if you have other questions in the comments. Hopefully that is helpful.